Okay, number 7 on worksheet 2 is a problem that has limits involving infinity. And first thing I'm going to do is just plug this in. 1 plus 1 divided by x minus 4. Okay, and I'll start with a zoom standard, and it shows up. We get an asymptote. Okay, and the first problem says, the first part A, says find a number delta such that f of x is greater than 1,000 if x is within 4 units on the positive side. Okay, so positive side, we're coming in from the right. Okay, and obviously the asymptote goes straight up, so we want to get f of x greater than 1,000. So the question is, how close do we need to get to 4 to keep f of x greater than 1,000? And so you can do this any number of ways. You can trace. So we can trace at 4.1 and not high enough. How about 4.01? Still not high enough. 4.001, I got a good feeling, and there we go. So at 4.001, we get 1,001. So 4.001 keeps us close enough. As long as we're closer than 4.001, we're good to go. In that case, our delta would be 0.001. Okay. We could get more precise than that, and we could guess around with the tracing. We could go to a table and make our table more and more precise, or we can do this algebraically, and I'm going to do it algebraically right now just to demonstrate that. So what I'm going to do is I want the function to be greater than 1,000, so I'm just going to set it equal to 1,000. 1 plus 1 over x minus 4 equals 1,000, and whatever value I get, I know that if I keep it closer to 4 than this value that I'm going to find, then it'll always be above 1,000. So the first thing I do is subtract 1 from both sides. 1 over x minus 4 equals 999. And then I can swap the 999 with the x minus 4, and I get x minus 4 equals 1 over 999, and then I'm going to add 4 to both sides. So x equals 4 plus 1 over 999. Go to my calculator if I want a decimal, and I get 4 plus 1 divided by 999, and it's 4.001001. Looks like it's a repeating. Equals 4.001001 repeating, right? Okay. The next part says find a number d such that f of x is within epsilon units of 1 as a limit of the limit as x approaches infinity. So the first thing we need to do here is figure out what that limit is, right? It doesn't tell us what the limit is, so we need to figure that out. So I'm going to go back to my graph, and you know, I'm going to use my table now. I'm going to go to my table, start at 10, and I'm going to go by, I'm going to start at 0 and go by hundreds. So I'm going to go down my table, and as x approaches infinity, this function should be approaching one particular value in the y column here. And it looks like it's getting closer and closer to 1, which makes a lot of sense. If you think about the function, as x gets very large, this fraction is going to get smaller and smaller. And so it's basically going closer and closer to 0. Well, 0 plus 1 is 1, so the limit is 1. L equals 1. Okay, so if I want to be within 0.001 units of the limit, and if we're approaching infinity, positive infinity, that means we're going to the right, then we're coming down from above. So we want to keep the function below 1.001. And so I can actually go back to my table and look for where it's below 1.001. I'm already plenty far enough out. I can go back quite a ways before I'm going to go up here, and here we go. Okay, 1,000 and 1,100, and 1,000 doesn't actually do it, because if I scroll over and look at this, this is actually 1.001004001, etc., etc. So I'm going to need something slightly bigger than 1. So I might go back to my table set and start at 1,000 and go by tens. And if I go over here, it looks like 1,010 is actually good. So I could say my answer could be 1,010. If you want to get more precise, we can go start at 1,000 and go by ones. And that's no good, that's no good. Looks like 1,004 is the best number I can get. So I'm going to say D equals 1,004. I could do this algebraically again as well if I wanted to. I could say I could take my function 1 plus 1 over x minus 4 equals 1.001 and solve for that, and I would get x equals 1,004, and that is my D value. So there you go. There's worksheet 2.